So again, I would encourage you to just try these problems on your own and then watch the video to check your answers or as you struggle. So here it says, how long will it take for less than 1% of the original sample to remain? So it's a percent. So I am going to start with 100%, and I'm going to decay until it's less than 1%. So I decay 50, 25, 12.5, 6.25, 3.125. Then I'm going to get lazy and say about 1.5, which is not less than 1%, but now I'm going to say about 0.75. So it's taken 1, 2, 3, 4, 5, 6, 7 half-lives. So 7 half-lives times the half-life of radon 222 is 3.28 days. So I take 3.28 times 7, and I'm going to get 22.96 days. Okay. You could say maybe a little bit less than that because, but you know, somewhere in the realm of 22 to 23 days is what it's going to take till we're less than 1%. So that's how I'm going to do that first one. Next, it says, how long will it take for less than 0.1% of the original sample of hydrogen-3 to remain? So I'm going to start again with 100% because that's a percent one. I'm doing the same process that I did before. And I keep going, 6.25, 3.125, 1.5, 0.75, 0.375, be what, 0.1, so 0.375, and you're welcome to keep doing this on your calculator. 0.375, come on, 0.375 is going to be 0.1875, okay, and I divide that in half, and now I get 0.09 something. So I had to keep going. Again, I would encourage you just keep doing it in your calculator, and I'm going to get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 half-lives. So 10 half-lives. Hydrogen-3 is 12.3 years, so 12.3 times 10 is going to be 123 years approximately. So again, looking for those key phrases like less than. The percent tells me start at 100% and decay till I get to that point. Next problem says, given a sample of atoms with 1/64. So since it's saying 1/64, I am going to start at 1 because it's a fraction, and then I go to a half, a quarter, an eighth, 16th, 32nd, 64th. Okay, it took 1, 2, 3, 4, 5, 6 half-lives for that. So 6 half-lives is a total of 3,000 days, because as I look at this problem, this took 3,000 days. So 6 half-lives, I know all half-lives are the same. So 6x equals 3,000, which is going to give me 500 days is each half-life. So each half-life is 500 days. And that's how I'm going to go about solving that one. The last one, it says the activity of a radon sample is starts off at 32 becquerels. How long until the activity is less than 3? So I start at 32 this time because that's my starting point. I decay to 16 to 8 to 4. Notice key phrase less than 3. So I got to go one more to get down to 2. So this takes 1, 2, 3, 4 half-lives. 4 half-lives. The half-life again up here of radon is 3.28 days. So when I take 3.28 times 4, I'm going to get 13.12 days. And again, you might say, well, that's way less than 3, so maybe I could argue it would be like 12 days. That would be fine. Again, if it was a multiple choice, you could select the answer from that. But this is the process you're going to do for solving half-life problems. Show your work, show your setup, and then walk through, and you're understanding the process that the half-life doesn't change, but the activity cuts in half each time.